Hey Wild Ducks. Welcome to our technology podcast. It's my pleasure to introduce the avatar of your host, Jerry Cuomo.
Thank you, RJ. Welcome folks to the Wild Ducks podcast. Our series brings a personal and behind-the-scenes touch to trending technology topics and the innovators behind the tech that challenge conventional thinking. Question: can AI transform the way we experience sports? Well, today, we're excited to have Aaron Baughman, an IBM Fellow, as our guest. Aaron has been at the forefront of AI in the sports and entertainment industry for over a decade, pioneering technologies that elevate fan engagement and redefine what's possible in sports analytics. Aaron and his team of Wild Ducks have won multiple Emmy Awards for their groundbreaking work in transforming the sports viewing experience through AI, particularly for events like Wimbledon, US Open, the Masters Tournament, and ESPN Fantasy Football. Listen in as they explore the fascinating world of AI in sports and the challenges and triumphs that come with it. And with that, I'd like to welcome Aaron.
I'd like to welcome Aaron to the podcast. Welcome, Aaron.
Well, thanks so much for having me. It's an honor and pleasure to be here.
Oh, the honor is all on this side. So we have lots to talk about. So without further ado, I'd like to jump into our usual first question, which is, Aaron, can you share with the listeners and viewers, in this case, why you love doing what you do?
Sure. Yeah. So, I mean, first, it's just a pleasure to be able to work on some of these cutting edge technologies. Throughout my career, trajectory, I've been working on pattern recognition, machine learning, AI, and now generative AI. Mm-hmm. And within the sports entertainment area, where I've been in the last decade plus, I'm able to bring people together with what I call social cohesion. It doesn't matter gender, creed, race, but we all go watch sport.
That's right.
And then these technologies can be personalized in different ways and bring people together, but it can also create these serendipitous moments where you're like, wait a minute, I never thought about that, or I never thought about watching this player,
That's right.
And then you can share all your different perspectives on social media that relate to some of the AI technology outputs that they have.
Mm-hmm, mm-hmm.
The other part why I really love doing this kind of work is that I can go out to a party, I can go out to dinner, and then I see someone on their phone, and I'll sort of look over my shoulder. I'm like, wait a minute, what are they doing? And they might be on the ESPN Fantasy Football
amazing.
app.
Yeah.
Right? And that's our work. So our work is just very persistent throughout the world. So
I love that, Aaron.
Fun.
Yeah, sometimes like when your work, albeit many times completely valuable, if your work is figuratively in the basement and it's behind the scenes and not a lot of people get to appreciate what you do, that's one thing. But in your case, it seems like, as you said, you can go to a party and bump into someone that's using an app that you actually worked on and get instant feedback and watch their expression. So that's priceless.
Yeah. And something that sort of sparks my memories is sort of unintended circumstances that happen. Mm-hmm. Where sports is serious business. Mm-hmm. Where people might look at a prediction and they'll be like, wait a second, I might want to invest, some sort of capital because of this,
That's right.
Prediction.
Yeah.
And a prediction has a certain confidence level with it.
That's right.
Sometimes that confidence level is glossed over, and people think of it as like 0 or 1. They're going to win or lose. There's nothing in between. And then when it doesn't turn out in their favor, it could be very, very interesting with what happens.
What do you mean by interesting, Aaron? That's a little scary.
Right.
Oh, I hope no one's looking to break anything of yours.
Exactly.
But they are predictions. They are predictions with a confidence level, as you said. And, I'm pretty confident that Serena is going to win that match, or, the Lakers are, in it again. But
yeah,
you have to look at the confidence level, and we have to not stop being humans, which is use our intuition and all of that kind of good stuff. So yeah, I appreciate that. I really appreciate that. So tell us a little bit about your background. So how did you get involved with, I would say, both AI and sports, fan experiences and all of that kind of good stuff?
Yeah. So, I started out as an intern at IBM back in 2000.
Wow.
And then also 2001, were sort of my 2 summer internships. And I was able to began to get into software engineering. So that's where it started, coding, developing. And then in school, I started getting into the biomedical space, where I was able to combine algorithms and sort of these neural network, pieces and how the brain works. And it just really sparked a lot of interest. And long story short, I found myself at the National Institute of Health, where I was a volunteer, and I was able to watch how do you turn off portions of someone's brain, right? It sounds like magic, but they have these electromagnets. They're called transcranial magnetic stimulation, and if you turn it on and then you put it over someone's skull, it creates this virtual lesion, and you can really turn off a sector of the brain and then see what happens, right? It's just this experimental thing, right?
Yeah.
And so putting all that together, I then, joined the workforce with IBM and did a lot of biometric work. So, that was right after 9/11 happened, facial recognition, voice, iris, a little bit of gait. And that sort of brought, sort of this AI pattern recognition, multimodal pieces together.
And Aaron, so you can place your or kind of connect your healthcare work around the brain and how the brain functions to AI and how neural nets and AI, quote unquote, brains function. Could you share a little bit of insights that you've gained along the way around the connection there?
Yeah, so I mean that's sort of my passion. I'm trying to use Mother Nature as our teacher and to look at how do we as humans work. And a lot of what we're engineering, right, are these algorithms that sort of emulate how the brain works. So for example, these large language models, the very dense neural networks, right? So all these neural networks, transformers,
billions of parameters.
Exactly. And if you think the word billion, trillion, it's just growing and growing, right? We have this part in our brain called the premotor cortex, where we have these very densely packed, neural networks that also process information. And so these large language models and the premotor cortex are very similar, but the differences start to come in, like the hippocampus, where we have memory, and we're starting to design systems that also have memory, where we can read in and write out, different types of weights. And what's interesting, for example, what is it? Google came out with Gemini, right? And they have what I think it's called Gemini Nano, right? But the smaller models, and in the brain, there's these other parts of the brain where we have less dense connections that sort of have areas that are experts at their own areas, right? And so being able to distill knowledge from these large language models to smaller experts, in a sense, is a bit how the brain also works, And it's
Aaron, we've been a species a long time, and science and all of our evolution, we still don't quite know how the brain works. And we're getting much better at mapping it and understanding, like what you just alluded to earlier. But I also hear similar things about the creators of these large models don't even sometimes know exactly how they're going to behave. And the connections between that, I think, is fascinating. Like, hey, if a human created this with their own hands, they should at least know and be able to expect the expected, but it's not always the case. Is that true? Or
Yeah, because it's so intractable, because there's so many mathematical equations that are going on at the same time, and then when you sort of do this Cartesian cross product, there's so many combinations where it's just unfathomable as to how can we understand how does this work, and the human brain is the same way. It's so complex. It's probably more complex because it's not computational, right? In essence, there's lots of different chemicals, right, that happen in the brain, whereas neural networks have lots of weights, and they have like this weighted sum and activation functions, but it doesn't have things like dopamine or all the different neurotransmitters. But what's fascinating is the notion of hallucination.
Yes,
right? I mean, it is a real difficult situation, right? And just being able to detect it and mitigate it and trust it.
How are we doing with that, Aaron?
So back to sports, right? So in a few days, actually, the U.S. Open starts. So let me say U.S. Open tennis, right, starts in New York City, and we're going to have lots of generative AI that's going to create content, right, about pre-match, post-match. It's going to be long form, short form, and some of the challenges that we have, and this is industry wide, right, is that sometimes these models make content up, right? It just doesn't make sense. You're like, where did this come from?
Right.
Right. And because it wasn't in the context.
And the scary part is it's plausible. I mean, if you read it very casually and quickly, you're like, yeah. So you have to, again, you can't stop being a human. You have to continue to be curious and challenge things and verify and all of that. So what are you doing? What kind of guardrails are you thinking through here?
Yeah, so we created this funnel, right? This like trustworthy funnel where we started very simple, right? Where we have different regular expressions, right? That just try to match and make sure that the output looks like what we're expecting in a sense. Then we go further down and we say, okay, do the numbers match? Because we put in context. We do few shot learning, to help guide it.
Yeah.
Sometimes
provide a few examples.
Exactly. Yeah. And so we compare the examples that we put in to the output, and we make sure every number in the output maps to some example in the input, right? And then the next part is we use a large language model as a judge. Right. So we ask another large language model, what is the novelty? We want the novelty to be almost like zero, because novelty means, did you make something up? Right. Is it brand new compared to the content that we put in?
That's right.
And then what's the relevance towards the domain? Right. So that's one of the other. And then we ask it to check the facts. Right. So those three metrics we combine together. And then at the very bottom, most important is we do have humans, right, in the loop that can, look and make sure that it's on point, because lots of times this content is very subjective, where maybe, one stat, let's say, someone had 4 aces, but is that a significant stat? Well, it depends. It depends on how many sets were played, what the gender is, who the player is, right? And so some of that interpretability comes from humans as well, so it's a trade-off between
absolutely
creativity of the model versus control that we want to have with the human, and we always land somewhere in between. But it's an open research area, right? And it's exciting, and I can't wait to see what else we come up with and what we as humans come up with, right?
Aaron, has there been a sport or a fan experience related prediction or output that has made you or a fan that you kind of witnessed go, wow?
That's a really good question. I think I would go to Wimbledon. It wasn't this year. Well, I'll get to it this year. But first, last year, we predicted that Djokovic was not going to win, right? That Grand Slam. And he is always, usually the winner, right, of that Grand Slam. And what we had Alcaraz winning, right? And it was, I think it was kind of close. So we said 55% Alcaraz was going to win, 45% Djokovic. And when people saw that, their jaws dropped. They're like, wait a second, what's wrong with Watson, right? How is this possible? How can Alcaraz be predicted to beat Djokovic? And we were getting pressure. Should we, write something about it? Should we take down our prediction? But we stood firm and went into that match with that prediction, and it turned out Alcaraz won. Right? I was watching that match, and I was sweating. Right? I was thinking, is Alcaraz going to win this or not? And then we swing to this year, and it was the same matchup. It was Alcaraz versus Djokovic. And our prediction came out that Alcaraz was going to win again, except it was more confident. It was like
amazing,
like 60%, Alcaraz. And the same thing happened, right? It is like, are you sure you want to go with this prediction again? I was like, hey, this is the data. This is our prediction. Let's stick with it. And it happened again, right? Alcaraz won.
So Aaron, I'm going to ask you, if you don't mind, to take out your crystal ball and look into it and share what you see. Where is this evolving? And as an avid sports fan, and I was born a New York Jet fan, which is something I can't help, but I accept.
Sorry. Yeah.
I was going to ask you to look into the crystal ball and say something about the Jets, but honestly, it is what it is. So where do you see this going?
Yeah. Well, I think this ever evolving relationship between human and technology is going to keep merging together. Where it's going to be a lot of multimodal pieces working. So touching all of our senses. so that we can better understand the world around us, but also augment what we can't see, like these hyperspectral bands. We can't see all these invisible signals that only IoT devices can get. But I think that we're going to be able to understand the world around us better, to make much more complex and tractable for us decisions by all these aids. But I do think AI is going to use not just classical computing, but I think quantum computing.
Oh yeah.
So moving a bit around off of the von Neumann type computation. So I'm really excited about that and where quantum's going to go. There's this other field called DNA computing. It's been around for a while, but it doesn't have the attention, right, that quantum has, and there's probably several reasons for that. But that being said, there could be other types of computing that just pops out of nowhere, where it's like, oh wow, we can encode a problem in these different chemicals and drop it into a bucket and put sort of restriction enzymes and it computes something, right? But I think these multimodal computation paradigms are going to come together to solve problems in new ways. So I think we're at a cusp, right, where we have lots of possibilities, and humans being centered to all of it, being aided by AI and working together with AI.
Wonderful. Well, Aaron, on behalf of our fan base here, so to speak, we'd all like to thank you for joining us, and thank you for doing what you do. And I'd love to have you back again sometime.
Sure. Thanks again for the opportunity. And I would encourage you to watch the U.S. Open and see our work. And then fantasy football starts. We're working with ESPN, so download the app and you can see our work. So it's pretty neat.
Will do. Thank you, Aaron.
All right. Thanks so much. I appreciate it.
Well, that wraps up another episode. I'm pumped to try my hand again at ESPN fantasy football, though with my track record on New York Jets picks, I might need some AI luck. Oh, and don't miss the US Open to see how AI and technology can reimagine how we enjoy sports events. And speaking about AI, did you hear Jerry has a new book out called Think Artificial Intelligence? Jerry is donating royalties to the St. Jude Children's Research Hospital. So, buying is really a form of donating. Once again, we'd like to thank Aaron, and we'd also like to thank you all for watching. On behalf of Jerry Cuomo, IBM Fellow, and Wild Duck, see you again soon. Bye.